Let's start. Hello everybody, my name is JEEConf, and today is my first presentation about, it's a technical presentation by the way. You may be surprised, but I still know how to do stuff in Java. I don't only know how to tell you how to find a job. So today is a technical presentation about WebSockets, which is in my opinion probably one of the most interesting development in the web area, not only in the web area. So a couple of words about myself. I work for a company called Systems. We have people working in the United States, and we have people working in Ukraine, in Russia, in Belarus. We have people, when I see people with this label, we have 7 people over here at this conference. So today, roughly, we are like 50 people or so. We write books, and the upcoming book is this one. It's available for free on the internet. O'Reilly allowed us to keep publishing drafts as they become ready. It's about enterprise web development. It's not for Java mainly it's for JavaScript Frontend. But all authors of this book are working for our company. I'm being one of them. At the end, you will see the link to that website where you can read the book, and if you like. And what's the plan for today? Today I want to gradually take you from traditional way of getting data on the front end by doing HTTP requests and responses, and all the way to the WebSockets. We'll talk a little bit about server-side events, or server-sent events, and then about WebSockets. You'll see a demo of how we do things using different technologies, and then you will decide if it's something that you'd like to explore more. Importantly, we need to understand the differences between network communications done as a request-response mode versus two-directional mode, socket-based mode. So this is what we will be talking about. This is how we're going to cover the whole thing. So what do you think about when you look at this picture?
Somebody can go in one direction.
Exactly. It's a narrow bridge, right? If a group of chickens from the other side will approach the same bridge, it won't work, right? So, which means if we have a connection, if you have a bridge, you can use it one way or the other. Not at the same time, right? I'm sending a request to the server, I'm being a web page, and I am getting back a response. So that's a request-response mode. It's a half-duplex mode versus full duplex. If you would have round trip, if you would have a chicken going back and forth at the same time. So HTTP is a protocol. What first word comes to mind if I would ask you, give me like a major characteristic of HTTP? What would you say? Just one word. Exactly. Stateless. It's a stateless protocol. I don't remember what happened in the previous state. I make a request, you give me a piece of data, I don't remember what was in the previous case. If I want, I can create session management, of course, I can store it somewhere, but in general it's a stateless protocol. I want something else, I make another request, and I get something back. Again, connection, give me the data, coming back. And there are 3 major modes as HTTP is done in traditional way. These smalls are kind of hacks. It's not the way, it's not the best way, but it's a way. It's something that people try to find a way around the limitations that we have only a request response, only an error bridge, so to speak. And these are called polling, long polling, and streaming. What is polling? For example, I want to see multiple updates on a web page. In many cases, you go to a web page and something is flashing like. I work pretty often for clients from Wall Street, and we're talking about financial applications. And in the United States, many people are investing into stocks. It's not only they keep money, cash in the mattress or something, but they put in the bank and they invest into different stocks, and the stocks go higher, or they lose money. But it's like a game that we enjoy. So people have investments and they watch how my investments are doing. So I go to a web page, Google Finance, Yahoo Finance, or maybe a brokerage company. I keep my money in, and the screen is flashing. Somehow, it's a web page, right? And I just said a minute ago, it's a request response. I didn't make any responses. These are my hands, and everything is flashing. How come? So polling. What is polling? Polling is every specific interval a web page makes a request for me, saying every 2 seconds or 3 seconds. It's a parameter. And polling means, say for example, I want to see new prices for Microsoft stock. And they are changing, the market is open and people are buying and selling. I make a request, my page makes a request. Give me a price for Microsoft. It didn't change, but I still make a request. Another, do you have something for me? 2 seconds later, no. Do you have something for me? 2 seconds later, no. It's like, imagine you're driving a car, your kid is sitting on the back and he's asking, Dad, are you there yet? No. Have you arrived? No. So this is polling, right? So, for nothing, I'm asking for nothing. Do you have it? No, I don't. All right. So every question is not as innocent as you think, because you use system resources. You bother the server, right? And you're a Java guy, so you know that every request requires some system overhead on the server side, maybe like an extra thread or so. So this is polling. Give me something. Give me something. This is a disadvantage because you're bothering the server for nothing most of the time, or often. The advantage is that you're not keeping a connection open. Give me something, you have nothing, I'm disconnected. So in this regard, it's a little bit better, but it's polling. So, first connection, no data, I have this thing. No data, and then again, connection, no data, connection, maybe you have some data. Next, so what they invented as a workaround, they thought it's not a good idea to poll every time. Maybe we can do long polling. It's also kind of a hack. What happens is a client makes a request. When I say a client makes a request, again, user is not typing anything, AJAX, right? So you can do an AJAX request from the page without user interaction. So a connection call is made, but the connection is being kept alive. Till when? Till the server has something for me. Either this, or maybe a timeout happens. So let's say I said, unless I have a request within 60 or say 5 minutes, hold the connection. So at the bottom of the slide I put this is also known as hanging get or pending push, pending post from HTTP, and there is a technique when the server returns a code, HTTP code, I don't remember, it's either 203 or 202, saying that I'm still working, I'm processing, I'm not done yet. So this is long polling. What's the advantage? You don't go back and forth for nothing. So you make a request and you wait until you get something from the server, and then the client gets it back. Usually I use this example. Imagine a party on the 10th floor of the building. It's a 10th floor building. People are drinking, having a good time, and then someone, once in a while, they want to go for a smoke downstairs. So long polling is like imagine an elevator. Elevator always is waiting on the 10th floor until somebody wants to get a smoke. This guy goes downstairs, and then the elevators go back again to the 10th floor and is waiting, right? So it's kind of a long poll. If the data is changing real fast, there is no advantages of long polling compared to polling. Because you always have data pretty much, so request, oh, you got data, so you go back. But still, it's an emulation of connection and emulation of a situation, like as if the server pushes data to you. Even though it's not exactly like a clean way of doing things. Streaming, YouTube, right? Over HTTP. One connection in the beginning, connection is being kept open, and frames of all these videos are pushed to you. It's called streaming. It's not a hack, it's also over HTTP. And it's fine from one extent, from one point of view, but what's not good about it? If the content, if all these requests go through some proxies, these proxies may decide to buffer the request. Because of that, you will get some slowness, sluggishness. In some cases, proxies won't like the content, and you may lose a connection. So it happens. But no matter what technique you use, polling, long polling, or streaming, it's still HTTP. And now, the major bad thing about HTTP is what? Overhead. We have HTTP header. When you go in HTTP request, you have a header, and we have a header in HTTP response. So if you will request a piece of data, say 50 bytes, a request will be several hundred bytes of header data alone. And I'll demo it to you pretty soon. If the data is coming back, you have a response. Another 2, 3, 400 bytes, depending on the situation, on top of your little piece of data. It's not that important if you want to find the weather, for example, weather forecast. You click on the button, you're going to wait. You don't care that much about how long does it take. But think about the server side. If you have 10,000 requests at the same time, and the server needs to push back 10,000 times, multiplied by several hundred bytes. It's important. It's already adds up. And again, coming back to some important time-sensitive areas like real-time trading is a pretty typical application that not a typical, we have several applications done in our company. Every millisecond counts. You cannot even imagine if it makes a big difference. People can make or lose a lot of money if we get a response not in, say, in 10, 20, 30 milliseconds. Think about it, 1,000th of a second, but longer. So while it's nice to learn how to write an application by the book, all these nice design patterns and everything, when it comes to these kind of applications, people don't care that much about design patterns.
Can I have a question?
Speed is the king. Yeah, 1 second. So I need to shave off these extra 10 milliseconds. I don't give a damn if it's a singleton or if it's a decorator or if it's a disruptor, whatever. I need to cut it off. Your manager say it's too long. And you can say, I did everything by the book. No, it's too long. Yeah, what's the question?
The question was, why would you use HTTP protocol for the things where you need milliseconds? Why don't you use sockets, UDP, TCP?
Okay. Why do you use HTTP at all if you need milliseconds? Not so. Because sometimes you want to get access, you want to give access to your application to your broker sitting outside of your building outside of your local area network. They are on the road, and they have a device in their hand. They are behind the firewall. So I had a situation. It was a foreign exchange trading company, and they've been working all the time locally, and they wanted to try different markets. In Hong Kong, for example, it was a case. And for that, they had a choice: either create a data center with dedicated lines for TCP, as you are suggesting, or do nothing. Just give them the web interface. So this makes a difference. A lot of money is involved in that. So if you can do stuff using any device and HTTP and it's secure and fast, of course it's a saver. It's a great saver. I don't know how to do this. So this is an example of Yahoo Finance. In Yahoo Finance, it's google.com/finance. You can go in there, you can enter the security, or it's the stuff. You can enter it and it'll start showing you the prices and everything will be blinking. And if you will use this Google's developer tools, for example, as in this case I'm using Google Chrome, it'll show you the content. You will see how it's getting accumulated. How it's getting accumulated. You don't see it, I guess. But stuff is getting accumulated, prices are changing, and down there, using web developers tools, and I'll start another server, I'll show you more, you can watch what's going on the network, over the network. You can see bytes and headers and everything. HTTP request response. If you are using HTTP, you can monitor the traffic. And monitoring the traffic, it's a must for you if you're a web developer. Some people think that Java development is difficult. It's a lie until you get into this world. Because I've been in Java for 15 years. I'm still there. But I'm also touching those waters. These people are miserable. We live in a predictable world in Java. We know what's going on. Somebody is making jokes. Oh, you're still using Eclipse and I'm using IntelliJ IDEA. That's about it. That's the difference that you've experienced. In this world, people don't know where they are. What kind of browsers? Will it work or will it not work? When you look at the code in JavaScript, it's amazing. Instead of just making a call to a method like you are used to do in Java world, or you're spoiled, in there they write, oh, is there such function in that object? If yes, I'm going to call it. If no, I'm going to use some other piece. This is how they write code. Will it work in this browser? I don't know. It may. Talking about IntelliJ IDEA. So it's not even funny. So let's look at the HTTP request response demo. So first demo is HTTP request, then we'll talk a little bit about server-side events, and then WebSockets. So what's the goal? Who are the players? So what we will do? Server, GlassFish. I am using Oracle's GlassFish because I knew that the Reza will be here. So he will tell his boss that I was using GlassFish. And the latest promoted build number 88, dated May 8th. And pretty stable software. And it's easy to integrate it into Eclipse, in particular into IntelliJ IDEA as well. So what else I'm using? All three examples that I will show you now are about the same thing. I want to make a request to a server, to a Java server, and Java server has a generator, random number generator, emulate as if we have a price, as if we generate it. What is it? We will generate a random price and return as if it's the price of Apple or Microsoft or Google, whatever. This part is in GlassFish. The client is HTML5 application, HTML JavaScript, and we are using in this example XJS from Sanchez, the framework for developing UI in JavaScript. I'm going to be using Chrome, maybe some other browser. And also what I do like, there's a tool called Charles Proxy. It's a great monitoring tool that we used for a while. It's a free tool. If you will get annoyed that every 30 minutes it will ask you to reboot, then you will pay like $50 or so, and you're going to get excellent. So this is what you will do. So the goal is, I have hard-coded portfolio for 12 stocks in the Java side, random number generator. We will make a request and we'll try and we'll see if the server gets us a response. So what do we get? This is a glitch. Why don't you? I don't know what's happening, guys. Yes, this is not my screen. This is a set of monitor. Want me to move? I can move here. Or I probably would have to include mirror. Okay. This works. I don't know how it's going to do. There's a browser. It's going to be. Okay, so this is. No, I should do it right, guys. I'm going to do mirroring. Let me do mirroring because they're monitors. No, it is mirror. Oh, it's better. Okay, so this is a glitch. And let me go back to the browser. So this is the application, WebSocket API. I'm going to use the same application to demonstrate three different techniques. One of them is HTTP GET request, traditional GET. Then I will try to get something from that GlassFish using server send events, and then we'll do the same thing using WebSockets. So, but first, I will open up the Google Developers Tools or Chrome Developers Tools to see what's going on. So, see when you open it up, anybody was using it before or no? In the browser?
Sure.
Okay. So you open up the panel, it opens up the panel at the bottom, and you can monitor whatever you prefer. In this case, we want to monitor the network. Actually, let me do the console first. This request, I will enter the ticker over here. Ticker is the symbol of the stock, say MSFT, AAPL for Apple. I will hit the button, and it'll make a request, and it will give us a response, which I print on the console. So over here, you're expected to see what was the request and what is the response. APL. So this is, I want to get an imaginary price quote for Apple. So see, it prints. So request went through, and it returns to me this price. This is a random generated price. If I will go to network, I see that there was a request behind the scenes. It was a GET request. I got back 200 code, which is okay. When you click on it, you can see the headers and the footers. It was a very small request, of course, but there's a lot of extra data that went over the wire. See this request header? All this information went as a part. I just sent them AAPL. This is what I wanted to send over the wire, and I sent AAPL, and on top of it, I had all this header. When I got a response, similar story. Response headers are coming back. What I will do now, even though this Google Developers Tools is great help for web developers, I'll open up this Charles tool, which will show a little bit better the same technique. So you can monitor the traffic, you can sniff on the traffic using this tool. It has much more. So all requests will go through this proxy, and this proxy will tell what goes in, what kind of request I'm sending, what do I get back. Besides that, it has an excellent feature called throttling. Throttling. It's about testing with slow, if you want to test if your application will perform nicely with slow connections. You can imitate a situation when you have a slow connection of this size or faster and so on. I will not go there, but I'm just telling you that it's available. So let me refresh the page. I'll make it a little smaller. I'll grab it. Okay, so behind the scene, over here in Charles, you will see a GET request as I will make it. So I don't need this anymore. Say MSFT GET request. See on the back over there? It was a GET request. It's my local host 8080, which this is where my GlassFish is running. And this is what's happening. I am making a request, and in this overview, it tells me what? Look at this. The request header size, 434 bytes. See that?
You can't see that.
You can? At the bottom, somebody's head is there. Maybe. It's not you. This way is better, right? Look at this. Request size, 434 bytes. Response header size, 268 bytes. So we are talking about 700 bytes total, right? Went over the wire. For just one little thing, I just wanted to have send a MSFT, and I want to get back a little string of 40 bytes. And this is what's happening. Imagine really heavy-duty transactions where server is pushing data. Not that great. The response size is 57 bytes. Actually, this is a meaningful something that came back to me. Look at this. This is what I received back. A little piece of JSON as a response to my MSFT request, and this was the price. 57 bytes, but actually we are talking about 700 bytes process. So, as you can see, it's not that great. All right, so now let's get back to the slide. Let's go back to the slide. What do you get now? So how this was processed? It's a pretty simple REST request. On the server side, again, it was deployed under GlassFish. Up on top, you can see this path annotation with stock. And if you have stock/ticker, for example, the word stock and MSFT, then this request will be directed automatically to this get random value method, right? So this path parameter works. It's pretty simple. So there is a special, very nice library by Google called JEEConf. It can take your Java in the instance of an object and turn it into a string of JSON format, and all the way around. Take a string in JSON and turn it into Java. One liner, very simple. You're adding one jar to your project, to the class path, and it works. So in this case, we're saying JSON, convert it to JSON, convert what? A simple Java class random stock generator, get data for ticker. This is a moment where we generate this fake random price. But of course, this could have been a real request to the server, and we would get a real data. It's a pretty simple thing. What was on the client? On the client, when I hit that button, get the price or make HTTP response, HTTP request, this was an AJAX piece. Again, it's not a pure JavaScript. We are using XJS, as I said, framework. So, but still, at the bottom, actually, let's look at the stub. At the top, REST URL variable REST URL is equal HTTP, and we get default values from document locations. This is a default browser API. We concatenate host where this code came from. In this case, it would be localhost 8080 where my GlassFish is running, and we are attaching location path name REST and stock, and then we attach a ticker. So when the particular method will be called, it will know that I want a price for MSFT or AAPL or whatever else. And that's all. Then we do JSON property, parse the response, and This is done. So this is how it was done using regular HTTP. Then I remember all these discussions during the pre-Java EE6 implementation, and in particular Servlet 3.0 discussions, what and how it could be implemented, and all these comment discussions, how to do these kind of things. I don't remember. I think it was included only in Java EE6. I may be wrong, but I don't think it was before. The server sent events is a different way, so they offered you different ways of dealing with the situation when a server needs to push data to a client. In some cases, you have an application where the main use pattern is server is pushing, not the client is hitting, but the client is hitting, but we are pushing the price post, for example, or something. So for that model, they came up with a server-side event specification and implementations, of course, and it works. It's also pretty simple, and you are substantially lowering the amount of bytes going over the network. Initially, it's still you make a request, and the client makes a request, HTTP, and then the server keeps sending data back using that connection. But what's important, we are still going over HTTP. This is not sockets. This is HTTP, but one request, then push, and then disconnect when need be. And these pushes are also having particular format, and I'll show it to you in a bit. On the client side, in a browser, it's also standard now. In all browsers they support it. There is an object called event source. This is a JavaScript piece. This is also, by the way, event-driven model. So you create an instance of event source on the client in the browser using JavaScript, and you subscribe to events on the server. What kind of event? Up to you. It can be any custom event you want. Of course, you will need to do open connection first, and then you subscribe. But you can subscribe to any events you like. So this is an example what you see in the browser. This is JavaScript. So for example, in my case, I'm pointing at the local host 88 against my GlassFish, and this is I want to create a new event source object that will connect to that URL and will be waiting for events. For which events? There are some standard events, such as open, for example. When connection is open, if you believe that something should be happening when the connection is open initially, then you write it as an event handler or as a callback in JavaScript up on top when connection is open. In here, I also add event listener to price change event. Maybe there is some important event that is called price changed, price of stock or price maybe on eBay. It's an auction. Then you subscribe for price change, assuming that the server will push you an event that is called price change. So maybe in this example, I show you that you can use JSON. JSON is a standard object in the browser. All browsers support it. And you do parse data. Whatever you will get back from the server will be sitting wrapped inside the event object. The event object has a property called data, and this is meat. This is your data, formatted in a special way. And in case of error, you may be listening to errors as well, of course. Now, what about the server side? The server is your Java server, of course, and what you need to do is you need to start sending data to the client, and as you know, there are different MIME types. In this particular case, MIME type would be text event stream. You're streaming data. And in which form you are sending data back? Right in the middle, I show you data, colon, and curly braces, the information that you need, and two end-of-line characters. This is a must. Every message in server-side event must start with the word data, then the payload, and then two end-of-line characters. And GlassFish is publishing it using Jersey. Jersey is an open source framework which is implemented in GlassFish as well. And an example a class broadcaster, and you start broadcasting event to the event output. Pretty simple code. In this particular case, I'm doing using timer, and in this timer, since server sent event, it was not too reliable, overly reliable. It would be killing the application after a while. I was trying to push it real hard, like with WebSockets. I'll show you in a minute. With WebSockets, I was pushing 50 messages per second to the browser, and it was working fine and easy. And this guy was dying at this speed. So I lowered it every 300 milliseconds. I'm pushing the data to the client. And a couple of other pieces of code. Let's skip. Let me show you how it works. This time it's fine. All right, so I will subscribe to server-side event, but first let me go to Charles. I will clean it. These leftovers from the previous connection, right? Now I'm going back here, and I will subscribe to server-sent events. Let me open up this little panel down there. I subscribe to server-side events, and see the data feed went in. So now the server is pushing the data. It's a server-sent event that we receive the data on the front. We are using over here this XJS with it's their own data grid. We find the cell to change, and if it's in green, it means the price is going up. If it's in red, the price is lower than it used to be before. But it works. If you go back here to Charles, you can also watch what's going on. This is our GET request, right? You click on the overview. Now it's much better. Initially, it was the same 700 milliseconds, but after that, we just push data. There is no request response anymore. So response lines keep growing, and this is the thing down there. I don't know if you see this at the bottom. The number is changing, right? The response gets accumulated. It's getting grow, larger, and in some cases, you may need to do a disconnect, automatic disconnect and reconnect if the browser will not survive, will not be able to handle that much. See, look at the data. This is the data stream that is coming back from the server. It keeps coming. Every piece of data starts with data, the word data, and then at the end, a couple of backslashes. So let's keep pushing the data. This is the payload. So it's much better than with regular HTTP request. So I will unsubscribe.
And you have to break a connection, for example, each hour to...
You have to break a connection. I don't know if exactly 1 hour. You have to do your testing with your data feed. But you may run into this issue, yes. Now, finally, let's talk...
Who is closing the GET connection in this case? The client?
The client should initiate, right? The client is initiating close connection. You can implement some fancy logic where on the server side you can implement the heartbeats, and you can figure out how fast is the network, and based on that you can decide, oh, now I will not be pushing data every like three messages per second. I will do only one, or even lower, and so on. But again, it's something that you would need to do. So we did this part. Let's talk about WebSockets. WebSockets is a standard W3C protocol. It was included in HTML5 specification, which will be finalized next year. But it was so good, this protocol, that they decided to create a separate standard to it. So it is basically a done deal. Java E7 includes WebSocket API as well, which is JSR 356. If you've been listening to the previous presentation, you probably in the stage A, you probably saw that. Every browser has this object WebSocket as well, so it's also a standard now in the browsers. So what happens? WebSocket is not HTTP. Important thing to remember: it is not. Only in the beginning there will be HTTP request to negotiate upgrade of the connection. The request is made to the server saying, "Please upgrade me. I don't want to be HTTP anymore." And if the server supports it, then it gets upgraded, and from now on, we are not HTTP anymore. It's a socket connection, socket-based connection, going over the same port, by the way. Nobody asks you or your system admins to open up different ports just because you want to use WebSockets. That's a great thing in the real world. So what's happening is, in the first initial, it's called handshake. And what happens is, they negotiate the upgrade of the protocol, the server is okay, then your connection is WebSocket. It's called handshake. So they agree, yeah, I'm gonna do this. And you will see this, when you look at the header, you will see there was a piece that's called upgrade in the header. Now, there is new URI schema. It used to be HTTP or HTTPS accordingly, not anymore. Now it's WS or WSS for secure. Security works the same way. WebSocket protocol doesn't define their own rules how to deal with security. Whatever it was in SSL before, reuse it, they rename it to TLS, but still, it's the same thing. Encryption is done the same way with all these keys and everything. WebSocket API is pretty simple. This is the front end. It defines what it's supposed to support. It can be in one of these 4 states: connecting, open, closed, closed, ready state. Now you specify on the client side, you specify handlers in JavaScript. What to do if this happens, if that happens. Again, event driven. And somewhere at the bottom there are 3 overloaded versions of the method send. You can send you can send HTTP, you can send binary objects and the like. Now let's talk about the Java side. Java and JSR 356 specify how to do things properly according to standards. Even now, many companies were developing for WebSockets, but they are doing the way they want. For example, Tomcat 7, starting from some minor release, supports WebSockets, but they force you to subclass some servlet, for example. We don't want it anymore, and that's why Oracle is coming up with a standard. And the standard tells you that you will be writing a Java pojo, and in that pojo you will specify 2 other classes. One class is decoder, the other class is encoder. So you will say, so whenever something comes in, give it to this decoder, let them figure out what to do with this data. Or if I want to give something back to the client, I'm going to give it to the class called encoder. Let them prepare the data to the client. That's what JSR 356 wants you to do. This is a good example how it's done. You are specifying a class that will be your endpoints on the Java side, and you prefix it with an annotation called server endpoint. You give it a value, again, very similar to JAX-RS idea. So whenever something comes with the URL that contains, in this case, stock generator, it means these are 2 guys for you. Encoder is, in my case, is my class that I wrote. Stock message in encoder class. If I want to send something back, this endpoint will send it to stock message decoder class again, which you need to write. You can encode it to JSON or maybe to some other, maybe SOAP. It's up to you what you want to do for encoding. And there is an onMessage method and onClose that you need to implement. Decoder, very simple. In this case, decoder is converting into JSON. Or sorry, decoder is converting from JSON. It came from the client, and encoder down there is doing the other thing. Now, one more important thing: heartbeats. It's very important in a real-world application to figure out that the client and the server are alive. Are you there? Are you there? Something that is supposed to check the health of the system. And there is a concept of ping and pong in WebSocket, and in particular in JSR 356 as well. Browser sends little signals, pings. Are you there? Are you there? Are you there? And the server responds, pong. I'm here. It's not something that you do, but it's available there. I don't have much time, but for now, just remember, they didn't expose the API that much. How to do manually, how to control pings and pongs. There are some certain things, but this is not exactly as free as, it's not exactly automated, let me put it this way. Okay, so let's close this panel. I will be opening using the same demo. I'm going to be, let me go again to Charles, clean this guy, and now I'll go back to this demo. I'm opening WebSocket connection. And it goes 50 messages per second. 50 messages per second, think about it. Regular HTTP. Well, let's look back. This was what Charles shows us. It shows us there was a request. Look at the line number 5 over here. See this upgrade? Initially there was a request to upgrade the connection. After that, pure, nothing else. Pure data load. Just 2 bytes. 2 bytes of overhead. Nothing more but 2 bytes. I don't have time for questions. I can stay here. You can ask me later. Just 2 bytes for the overhead. Think about it. Plus, not request response model. The data goes back and forth at any given time over the wire. See? Quick overview. Initially, this request was done once for 489 bytes. A request was a handshake to upgrade the protocol. Nothing else. And after that, the data, it just works. So in this case, I'm here in this browser. What's the name? It was Chrome. Let me move it, just let it to the right. Let me go to this guy. This is Firefox. I'm opening the WebSocket connection. It runs nicely in here and in there, as you can see. Now I can open up Safari. It can go forever. Yeah, of course, if you enjoy the show.
What about the client memory? What about the client memory?
It doesn't kill it. I don't know. It doesn't kill it that much. It depends on the browser implementation, of course. But it doesn't grow. I mean, I didn't run into the issue in this case. This is Safari. It works. So you want to stop it, you unsubscribe, and you close the connection, and it's done. You restore it starting from 10, version 10. And to finalize, I have only a couple of minutes left. Let me just tell you that this is what's coming back. No, there is a site called caniuse.com. If you want to see the support of a particular browser, you go there and you do a search on the technology you want to check. In this particular case, you do a search on WebSockets and you'll see all the browsers. As you can see, everything that is in green, it supports WebSockets for a while. I'm surprised, but this Android browser has some issue with that. But so you can ask people to use Chrome on the browser, I guess. And finally, this guy from HTML5, I mean, he works for Google, the lead of HTML5 writing specifications. He said this, I think it's important, that reducing kilobytes of data to just 2 bytes and reducing the latency from 150 milliseconds to 50 is far more than marginal. So in fact, these 2 factors alone are enough to make WebSockets seriously interesting to Google, not only to Google. And the use cases where to use them. As I said, live trading applications or maybe stock requests. Now, medical equipment, controlling medical equipment. It's, of course, the less data you send over the wire, the better. Controlling medical equipment over the web, think about it. Chat applications, multiplayer online games. When you want to communicate with people around the globe, you're using nothing special, just port 80 and HTML browser. Some social stream and so on. So I'm pretty much done, and this is the book. As I said, you go to the website enterprisewebbook.com. There you don't have anything to buy. These are raw draft. Raleigh allowed us to publish them as we write them. There are 8 chapters already, and chapter, which one is that? I think chapter 9 is specifically about WebSockets, and details about today's presentation, of course, you can read over there. The book will be published later this year. And this is my contact information, and that's it. Thank you very much. I'm out of time.